Let's discuss word problems again one more time related to graphs as well. This is about the practical application, right, that deals with the physics at a time, right? How we can use this linear equation in two variables in other branches of your subjects as well. Let's start. If a work done by a body on application of a constant force is directly proportional to the distance. Okay, so there are three quantities mentioned over here. First is work done, right? You must have studied in the physics. Work done is equal to force multiplied by distance. You must have studied that formula. So we are discussing about that formula over here. So first is work done. Second quantity is given force, but before force it is mentioned that it is constant. Constant means what? It is not going to change. The value is going to remain same. Sometimes we use the word constant for the number as well. That ax plus by plus c is equal to 0, where c is the constant, means whose value is not going to change. That is called as a constant. And third quantity is distance. So we have three quantities. First is work done, then force, and the distance. Out of these three, which is the constant? See, it is mentioned that force is constant. So let's continue reading. Distance traveled by the body, then express this in the form of an equation in two variables. Okay, till then, first of all, let's talk about this expression. So we have three quantities. Let's say work done, that is W, then force, that is F, next is distance, that is D. Now it is given that work done is directly proportional to the distance. So we will write over here that W proportional D. Now if we want to write in the equation form, we need constant, and see, we have force here, that is constant. The force is given constant, so we can write W is equal to F into D, right? So W is equal to F into D, right? This we have expressed in the linear equation. If you want to convert into the standard form, how you can do it? You want to shift F into D over this side, so that will become 0. So this is our linear equation in two variables. So far we were only using x and y. Now you must be thinking why we are not using it. This is physical quantities we have studied. You must have studied in the physics. So that's why we are keeping it as W. If you want to write in the form of x and y, then this is how you can express x is equal to F multiplied by y. This is somewhat it look like. I've just written for like familiarity, right? So you can understand, yes, this is actually a linear equation in two variables, not three variables. Remember, I'm repeating one more time that force is constant, whose value is not being changed. Let's continue reading further and draw the graph of the same by taking the constant force as phi unit. Okay, so what we are supposed to take the value of this constant? We are supposed to take 5 units. We are going to take value of s as 5 because it is constant. I told you that is not going to change. So let's continue from this equation. So what can I write now? W is equal to F. Instead of F, what can I write? 5 now. So 5 and D. Now it looks like that there are only two variables, right? You will get better idea compared to this previous equation that W is equal to phi D is linear equation in two variables. What are two variables? First is work done, yes, and second is distance. So I have two variables and I have relation as well. So this is my equation in two variables. And we are supposed to draw the graph of this one. Right, now graph of this one, very simply, right, we have done some graphs like this one that will help you to draw in the better way. The first one I think we discussed was x is equal to y and x is equal to 2y. This is what we discussed. Or was it like y is equal to 2x, something like that. Okay, now you can consider this as x is equal to 5y, something like this one, right? Now this will give you the better idea. Okay, w is equal to 5d, x is equal to 5y. That's it. You take some value of d. As a result of it, you will get the value of w, that is work done. So let's make a table. So w here, sorry, d there and w. So suppose if I take value of d as 0, I will be getting work done will be what? 0, right? Then let's take 1 over here. So if I take d is equal to 1, then my work done will be what? 5. The reason behind that is I am multiplying with the 5. 0 multiplied by 5, 0. 1 multiplied by 5, 5 only. So this is what we are supposed to do, right? We have the table ready. Now we can plot this. So let's draw the graph now. This distance I will be taking on the x-axis and the work done I will be taking on the y-axis. Okay, so first is 0, 0. The first coordinate is 0, 0. Second coordinate is 1, 5. When you take x is equal to 1, you get y is equal to 5. So let's plot it. 0, 0. That is what? Origin. Very simple. Both of them are 0. So that's my first point over here. That is 0, 0. Next is 1, 5. Remember, first coordinate is on the x-axis. So 1 here. Then I need to move up till 5. So here it is. Yes. Right? That's my second point. Now what I supposed to do? I supposed to connect them. So let's do it. Use the scale to connect this always, right? And you can extend further till as well. Okay. So this is what the line will represent. The equation that we have done, that is, what's the equation? W is equal to 5d. W is equal to 5d, right? So this is how we have write the linear equation in 2 variable. Then we draw the graph as well. Now let's move on. Are we still leaving something out or not? Okay, so 5 units. Also read from the graph the work done when the distance traveled by the body is 2 units and 0 units. Okay, so we need to find, okay, let's say there are two values of the distance. First is 2 units and next is 0 units. What will be the work in this case? And this we need to do with the help of the graph, right? You can do with the formula as well, but as it is mentioned, let's do with the graph. When distance is 0, right, you can see that work done is also 0. Now you must be thinking how? I'm taking distance on this axis and work done over the y-axis. I have already mentioned there. So if I take distance, first of all, let's start with 0. So 0 here, if x is 0, y is also 0. So I can write work done is equal to 0 units. Work done is equal to 0 units. Now come to the 2 units. How can we find from the graph about the 2 units? So for that, what we will do, we will extend this line of 2 where it is touching the graph. So it will be somewhere, right? Okay, so where this, okay, you extend the line of 2 till it touches this line. Remember, extend it upper side, right? Because we want for positive 2. And remember, we will only talk about the positive quantity. At this point, you can see that x-axis 2 and y-axis 10. Okay, now we know that x-axis means what? Distance. Y-axis means what? Work done. So what work done are we getting when we take distance as 2 units? That is, work done in this second case is what? 10 units. Even if you use the formula, you will get the same answer, right? 5 2s are 10. Very simple. So what we are getting is the correct answer. Now this is a kind of question that we have not discussed so far. The unique thing about that is we are getting the answer from the graph, not by just calculation. So it is also possible that you are being asked this kind of questions. Plot the graph Then you answer few questions from the graph. So this is how we solve the word problems. Now let's recall one time. So there were three quantities: work done, force and distance. So work done is W, force, it is mentioned that it is 5 units and it is constant. Now distance is D. So work done proportional to D. So we can write W is equal to FD. Now let's substitute the value of the force, that is 5. So W will be 5D. Now as we want to plot it, take some 2 points, then plot it. Afterwards, answer the question. That's very important part. When you take distance is equal to 0, we need to see in the graph, what do we get as the work done? That is 0. In case of 2 units, you need to extend it further, right? Upper side. And we come to know that the point is touching at this point 2, 10. So 2 is the distance and 10 is the work done. So this is how we solve the word problems related to application of linear equation in two variables. Let's discuss the last question of this chapter, that is very important. Let's start. Given below a linear equation that converts Fahrenheit and Celsius and vice versa. Okay, so there is a one relation given, F is equal to 9 by 5 into C plus 32. Let's write here, very interesting relation. F is equal to 9 by 5 into C plus 32. Now this is the relation between the units of temperature. There are two units of the temperature. One is Fahrenheit, another is Celsius. So if you want to convert temperature in Fahrenheit to Celsius or vice versa, Celsius to Fahrenheit, you can use this relation and modify according to your need. Now, why this relation is related to this chapter? First of all, see how many variables are there. F is a one variable and C is another variable. Variable means what? You know very well, whose value is being changed, right? Changeable. So this is the reason that we are discussing this relation in the mathematics as well. This is a very good example, practical example of linear equation in two variable. Fahrenheit is equal to 9 by 5 into C plus 32. So we are supposed to find few values. Let's start with that. First one, if temperature is 30 degrees Celsius, okay, unit matters a lot. Both of them will be in degree. So Celsius or Fahrenheit, that you need to focus properly. If temperature is 30 degrees Celsius, what is the temperature in Fahrenheit? Okay, so let's start with the first one. If it is given that 30 degrees Celsius is the temperature, then what will be the value in Fahrenheit? So let's start. We have the relation F is equal to 9 by 5 multiply by, instead of C, what we will write? 30 plus 32. So 5 ones are and 6 are. 9 6 are 54 plus 32. So 4 plus 2, that is 6, 5 plus 3, that is 8 Fahrenheit, degree Fahrenheit, right? So this is the answer of the first one. Very simple. You have the value of C, temperature in Celsius, and you want to convert into temperature in Fahrenheit. Very simple. Let's move on to the next one. So see what's given in the second part. Okay, if the temperature is 95 degree Fahrenheit, okay, it is given in Fahrenheit, 95 degree Fahrenheit, then get the answer in Celsius. Very simple. Okay, let's start. So relation is F is equal to 9 by 5 into C plus 32. So instead of F, I will be writing 95 is equal to 9 by 5 into C plus 32. Let's shift over here. First of all, always shift the addition and subtraction thing. Then go for multiplication and division. So 95 minus 32 is equal to 9 by 5 into C. Okay, so if we subtract, we get 3 here, we get 6 here. And okay, let's keep it 9 by 5, C as it is. And if we shift further, 5 will come into numerator and 9 will go into denominator. So let's start. 63, 5 in numerator, 9 in denominator, and we'll get the value in Celsius. So 9 ones are, and here 7s are. 7 5s are 35 degree Celsius. That's the answer. So temperature in 95 degree Fahrenheit, that will be what? 35 degree Celsius. Our temperature remains in the range of around 35 to 37, right? So when you see on the thermometer, you will be seeing 95 degree Fahrenheit. Generally, thermometer has the unit Fahrenheit, right? Not the Celsius. So this is how we solve the first two part of the questions. Now, let's discuss other two parts. Let's discuss other two parts of the question. Let's start with that interesting one. If temperature is 0 degrees Celsius, what is the temperature in Fahrenheit? Okay, here the condition is given that if we take 0 degrees Celsius temperature, what we will get the value of Fahrenheit? I think that's very apparent. Let's start. F is equal to 9 by 5 into 0 plus 32. So F is equal to directly what? 32 degree Fahrenheit. Very simple it is, right? That is third case. Okay, I think they're still in continue. If temperature is 0 degree Fahrenheit, what will be the value in Celsius? Okay, so here we are taking 0 degree Fahrenheit and we need to find the value of Celsius. So 0 is equal to 9 by 5 into C plus 32. Okay, let's shift here. So minus 32 here. Remember, 9 by 5 into C. 5 will go into numerator and 9 will go into denominator. So 32 into 5, let's check it. What do we get it? Here 5 2s are 10, 0 carry over 1, 5 3s are 15 plus 1, 16 and minus 160 over 9 will be the temperature in degrees Celsius, right? Or we can write over here that minus 1 by 60 over 9 degree Celsius. That's the answer. Then that's the question number 3. Now let's move on to the next question. If there is any temperature numerically which is the same in both Fahrenheit and Celsius, if yes, find it. Now this is very interesting case. What they are asking basically is, can we get some temperature at what value Fahrenheit and Celsius will be same? So let's start. F is equal to C is equal to, let's take X, right? Both temperatures should be equal. Let's check it can be find or not. So let's start. X is equal to 9 by 5 into X plus 32, right? Now let's shift this X over this side, not 32, because we want to find the value of X. Collect all the variables on the LHS side and numericals or numbers on the right hand side. So X minus 9 by 5 into X is equal to 32. So LCM is 5. 5x minus 9x over 5 is equal to 32. Here that is what? Minus 4x over 5 is equal to 32. So let's solve for the x. So x is equal to what? 32 multiplied by 5 minus 4. What did I do? 5 goes into numerator, 4 goes into denominator. So 4 ones are, and here 8s are. So x is equal to, see, minus will come over here. 8 5s are 40. So either you take minus 40 degree Fahrenheit or either you take minus 40 degree Celsius, your temperature will be same. So this is the number where we get Fahrenheit and Celsius equal. So these are the temperatures. Okay, let's recall. We took Celsius as a 0 degree, then get the value of Fahrenheit. If you take Fahrenheit 0, get the Celsius. The last case was very interesting, where Fahrenheit and Celsius should be same. So we have taken x, solve for the x and get the answer, that is minus 40 degree. At that temperature, Celsius and Fahrenheit, both unit will be, right? You will be getting the same temperature. Now what did we study in this chapter? First of all, we study about the linear equation in one variable. It's about the recollection of the knowledge. Then linear equation in two variables, about its standard form. We learn about the solution. We learn about how to find the unknown when the solution is given. We also learn how to make the linear equation when few conditions were given, or at some point we had 2 or 3 points and we wanted to make the linear equation. Afterwards, we learn how to plot the points and we draw the graph for the linear equation. Then we solve few word problems related to that, and this is also one of it. So this was the chapter number 4, linear equation in two variables.